So now that we've learned about the special right triangles in our first quadrant, now I want to talk about something about reference angles because we're going to use that information along with reference angles to be able to identify and evaluate angles all around the unit circle. So if I take a look at this 135-degree angle, when we are coming up with a reference angle, it's defined as an acute angle where the terminal side makes with the x-axis. So let's take a look here. The first thing you want to ask yourself is, in a 135-degree angle, what quadrant does that lie? And I just drew my normal xy axis, and we know that the 135-degree angle lies in the second quadrant. So what we have to do, we want to find the difference between this terminal side, right, and the x-axis. This forms our reference angle that I've just outlined here in green. This is our reference angle. And so to figure out what its measure is, we know this right here is 180 degrees. So we can just do 180 degrees minus 135 and we get 45 degrees. So this right here is our 45-degree reference angle. And we'll learn in just a little bit why finding this reference angle is so important. So let's go through several more examples. If we have 240 degrees, I want you to think about what quadrant that is in. Now, if I'm trying to find the 240-degree angle, we know that going halfway, that's 180 degrees. That's not quite 240, but we're not all the way getting to 270 degrees. So this right here gives us a 240-degree angle. And remember, we're going to use this terminal side of the angle that I'm highlighting it in green, and what our x-axis to find our reference angle. So what I've highlighted in green is our reference angle. And this time, to find our reference angle, we're going to take 240, because it's the bigger number, and just subtract 180. And we end up finding that our reference angle is 60 degrees. So this is a 60-degree reference angle. All right, let's keep going through some examples here. So if I look at this next one, if I've got a negative 60-degree angle, I want you to ask yourself what quadrant that angle is going to be in. And we know we're going to be moving clockwise. This is going to end up being in the fourth quadrant. Now, if we're trying to find what our reference angle, we're going to take this terminal side of the angle. I'm going to outline that in green. And then we're also going to take the x-axis. And so this ends up, it's just an acute angle. It's going to be a positive acute angle, but it's just going to be a 60 degrees reference angle. So now let's talk about some examples where we have radians. So here, if we have radians, we've got 5 pi over 6, and that's not quite 6 pi over 6, right? 6 pi over 6 gets you 2 pi. And so we know we're going to be over here in the second quadrant. That's going to be at 5 pi over 6. Now remember, I said pi is the same thing as 6 pi over 6. So here, my reference angle, I'm going to highlight here in blue, and it's comprised of the terminal side and the x-axis. This is my reference angle. And so to find that reference angle, I can just do 6 pi over 6 minus 5 pi over 6, which just gives me a pi over 6 reference angle. So this angle right here is going to be pi over 6. And that is an angle that we see in the first quadrant. And let's go through these last two examples here. Again, the first thing we want to do is identify what quadrant our angle is going to be in, and then determine what angle that terminal side makes with the x-axis. So 7 pi over 4, it's bigger than 4 pi over 4, right, which is just pi. If we come back over here to 2 pi is the same thing as 8 pi over 4. Well, you'll notice 7 pi over 4 is pretty close to 8 pi over 4, so we're going to come all the way around here to this point right here. It's going to be 7 pi over 4. And our reference angle is just going to be our terminal side of the original angle and the x-axis. So there's our reference angle. And our reference angle is just going to be 8 pi over 4 minus 7 pi over 4, which just gives us pi over 4. So this is a pi over 4 reference angle. Again, your reference angles should always be acute. They should always be angles that you would find in the first quadrant. So last but not least, let's look at this one. You're going negative 4 pi over 3. If I was going to draw this, you need to figure out what quadrant it's going to be in. You start at 0. This has a third, so we're coming over here to pi, which is the same thing as 3 pi over 3. Now, if it's negative, I'm going to be going in a clockwise direction. So if I go in a clockwise direction, I go through 3 pi over 3, and I go up here to 4 pi over 3. Excuse me, that should be negative 4 pi over 3. I may actually write this down here. Negative 4 pi over 3 is that angle. And so now to find my reference angle, I'm going to use my terminal side and my terminal side and my x-axis to figure out what that reference angle is. And then I can just find my difference here between 3 pi over 3 and 4 pi over 3. 3 pi over 3 minus 4 pi over 3. And I don't really care what my sign is here. I know it ends up being negative, but I'm really just looking at that pi over 3. This is a pi over 3 reference angle. That's all I'm looking for, is the difference between those two. Okay, so now we want to put this all together. And we've got this little acronym to help us figure it out. We already have found what the coordinates are in the first quadrant. We found the coordinates at pi over 6 to be the square root of 3 over 2, comma 1/2. And the coordinates at pi over 4 and 45 degrees to be the square root of 2 over 2 and square root of 2 over 2. And lastly, at 60 degrees, we found those coordinates to be 1/2, comma square root of 3 over 2. Now, I do want to point out the coordinates of our quadrantal angles. So if we're talking about this point here at 0 and 2 pi, if you remember, our coordinate is at 1, comma 0. At pi over 2, our coordinate was 0, comma 1. Now over here at pi, remember our radius is at 1 and the center of our circle is at 0, 0. So over here at pi, our coordinate is negative 1, comma 0. And then down here at 3 pi over 2, it's going to be 0, comma negative 1. Now, using what I've just filled in, you should be able to find all the values of different angles around the unit circle. Whether you're talking about positive or negative, you should be able to figure this out. Now, we're going to use that with our reference angles, our knowledge of special right triangles, and then also what we have listed here is all students take calculus. Now, before we talk specifically about that, I do want to identify each quadrant. I have referenced them, but this one right here is going to be quadrant 1. And then to the left, we have quadrant 2. And down below, we have quadrant 3. And lastly, we have quadrant 4. Now, this acronym, all students take calculus. What this tells us is which trig functions, and when I talk about the trig functions, you're talking about the basic ones, sine, cosine, and tangent. Which trig functions are positive in each quadrant. And so let me show you how we're going to put these acronyms. You're going to start in quadrant 1 with an A, quadrant 2 is going to be an S, quadrant 3 is T, and quadrant 4 is C. And let's talk about what this means. All students take calculus. Again, it's going to tell us which trig functions are positive in which quadrant. So all means that all of the trig functions are positive. The S tells us that just the sine is positive in this second quadrant. The T tells us that the tangent is positive. and the C tells us that the cosine is positive. Now, before you ask, I do want you to know, if you know in the second quadrant that only the sine is positive, we also know that the reciprocal function, the cosecant, is also going to be positive. And likewise, when in the third quadrant, when we know the tangent is positive, we know also that the cotangent would be positive. So we're going to take this information along with reference angles to figure out what exact trig functions are going to exist. Okay, so we're going to evaluate these trig functions using these steps. These steps will be really useful to you as you get the hang of how to evaluate these different trig functions. So the first thing we're going to do in this example, we're trying to find the cosine of 135 degrees. So I first want to focus in on 135 degrees, and I want you to tell me what quadrant it is in. Hopefully you're able to figure out that this is in quadrant 2. And if I look in quadrant 2, what is the only thing that is positive in quadrant 2? We see that it's S, which means that the sine is the only thing that is positive in quadrant 2. So if the sine's the only thing that's positive, that means that the cosine is going to be negative. And at this point, I would go in and put a negative in my final answer because I know it's going to be negative. I've already determined that. So once I've determined whether my answer is going to be positive or negative, I can go in and indicate that. Then what I want to do is figure out what my reference angle is. We know that 135 is in the second quadrant. And so then I need to ask myself, what angle is there going to be between that terminal side and the x-axis? And hopefully you were able to recognize that 45 degrees is going to be our reference angle. And at this point, what we need to do, we need to find the cosine of 45 degrees. And you can do that by just doing a general geometry triangle. We've got a 45, 45, 90, and thinking back to geometry, we know that our legs could be 1 and our hypotenuse could be the square root of 2. So the cosine of 45 degrees is just going to be 1 over the square root of 2, but you've got to rationalize that. So you end up getting 1 over the square root of 2 times the square root of 2 over the square root of 2. So that just gives you square root of 2 over 2. And we're going to take that and put it over with our final answer. So we know that in the second quadrant, our cosine is going to be negative, and then we pull the actual value of the cosine from our reference angle. So the cosine of 135 is going to be negative square root of 2 over 2. So let's look at another example. If we look at the tangent of 2 pi over 3, here this lies in quadrant 2. And if it lies in quadrant 2, the only thing that is positive is sine, so that means your tangent is going to be negative. So I can go in and put a negative for my answer. Now, if my angle is 2 pi over 3, I hope that you are able to see that your reference angle is going to be pi over 3. And you can go in and do a conversion here. Pi over 3 is the same thing as 60 degrees. And that can actually help us when we are forming our special right triangles, because we're trying to figure out what the tangent of 60 degrees is. And if we fill in our lengths of the special right triangle, we're going to have 1 for the short side, square root of 3 for the long side, and 2 for the hypotenuse. And so if we're looking for the tangent of 60 degrees, it's just going to be the square root of 3 over 1, or just the square root of 3. And so I can put that over here with my negative sign to get my final answer. Now the last one that I'm going to be able to do is this cosecant of 180. Remember that the cosecant is the same thing as 1 over the sine of 180. And if we look back, our coordinate at 180 degrees is negative 1, 0. And remember, we said that the x value is the same thing as our cosine, and the y value is the same thing as the sine. So the sine at 180 degrees is just 0. So we have 1 over 0, which is going to be undefined. Work this last problem and come check your answers before you pause.